Okay, last time we talked about kinetic energy.
Yay.
And kinetic meant moving.
Yes, sir.
Today we're going to talk about a form of energy that's the opposite. It's not moving, and we call it potential energy. Got that?
Yes, sir.
So potential means it has the capability of. A simple way of thinking of it is this is stored energy. And traditionally in physics, when we talk about potential energy, we talk about something stored because of its position. You've all noticed if something's held up and it goes off a slant, gravity pulls it down. And I'm sure you've noticed before, if you drop something, the higher you drop it from, the harder it hits the ground. So this is what we call potential energy. When I store something above something else, the higher I store it, the more potential energy is built up. Very, very simple idea. This is the one most of the chapter is dealing with. There are other forms of potential energy. There is chemical potential energy, and the way you usually see it is in a battery. It doesn't have to be in a battery. Energy can be in different forms. Sometimes you mix chemicals together, they give off heat. That's a form of energy. This is a chemical version of storing electrical energy. We mix a little bit of acid, we put it against copper and zinc, against the right kinds of metals, and it will cause an electron flow. But the battery does nothing until I plug it into a circuit and turn the on switch. All that is stored in here. It has the potential to give energy. You guys are potential energy. You have the potential of being good citizens. Well, maybe not Brandon. But most of you have the potential of being good citizens. Another type that you see a lot that's used in the world is what we call elastic potential energy. That's simply stuff held in something that's elastic or springs. If I stretch the spring, and most of you notice, the more you stretch the spring, the more you feel it pulling back. The more you stretch, the more energy is created. You could use the spring to launch stuff. Same with rubber bands. Anything flexible. Anybody who's ever used the bow and arrow, the flexibility on the wood and the string, it bends and it stores energy. You can get harder material to stretch. You can stretch it further and get more launch out of your arrow. So this is what we're talking about on potential energy. I mentioned for today in physics, we're usually dealing with the potential energy that has to do with height. So to get us going, we abbreviate potential energy with PE. In physics, PE means potential energy, not physical education. Don't panic, you don't have to get up and run. And the simple formula is potential energy equals mass, which we usually abbreviate as M, gravity, times gravity, which we multiply as, show as G, and height, which we'll show as H and measure in meters. So you'll normally see it expressed this way. Potential energy equals mgh. So it's three variables multiplied together. Now a little bit of review. Does mass times gravity ring a bell?
Yes.
Do you kind of remember how that rings a bell?
By pulling it?
Let me give you a thing. We're just going to take out this part right here. Mass and gravity. Remember, that's my abbreviation for remember. Remember, gravity is acceleration. So if I want, I can say mass and gravity equals mass times acceleration. Does that look familiar? Anyone know what mass times acceleration is? Remember Newton's second law? Force equals mass times acceleration. Awesome.
Joules.
Not quite in joules. Force is part of the unit of joules, and we're almost there, Brandon. So I could also say this is force times height. In height in meters. We also, if you remember, M and gravity, mass and gravity in physics, we call it weight. Mass times gravity is what we call weight. So if I ask for the weight of something, I'm asking for the force of something. And anyone remember the unit of force? We've done this one for the last 3 different things. Same as the potential energy. What's the unit for force? There you go. Thank you.
Neutral.
So force is in newtons, and height is a kind of distance. Instead of measuring distance this way, we're measuring up. What units do we use in physics?
What? Volume?
When I'm measuring distance, when you measured how far your cars went, what were you measuring it in?
Meters.
Meters. So this is going to be, our units are Newton meters, also known as, AKA, the famous joule.
Mark.
So potential energy is measured in joules. And we need the mass of something in the height. Following along? Measured in joules? Awesome. So just a couple things to help you out. Potential energy is measured in joules. And it equals mass, which is measured in kilograms, times gravity, which if you remember, gravity is 9.8 meters per second squared. You don't have to remember that part. Just remember the 9.8. Times height, which is measured in meters. One more time. PEMGH. Now, there's 4 variables here. The potential energy, the mass, the gravity, and the height. Gravity is easy to figure out. G is always going to equal 9.8. Technically 9.8 meters second squared. Unless I give you a value and say, what is the potential energy of this on Mars? But for today, let's keep it planet-based. We're not quite there yet. So, let's say I have a question that I want you to find the mass of something, and I give you the potential energy and the height. How would I rewrite the formula to solve for mass? I would have the mass, I would simply divide by gravity and height to move that over. So mass would be potential energy divided by gravity and height. We know what gravity is, 9.8. The other variable I may ask is sometimes I may tell you something has a mass of so much. Let's say we put Joe on a diving board. He looks pretty fit. We say Joe has a mass of 70 kilograms and he's at it and he's going to hit the water with so much potential energy, 30 joules of potential energy. What's his height? Well, I may want to rewrite this for height. Same thing, if I want height, I would divide it each side by mass and gravity. So height would equal potential energy divided by mass and gravity. I highly recommend on your notes you write down these 3 versions of the formula because it will help you get through it. Now, on to the fun part. That was my fun lecture. So you have a little reading that's going to go over the same stuff I did. What I would like you to do is I want you to create a little mini poster on potential energy. And the guidelines are listed there, and I printed them out, put them on your table. You're going to make a mini poster the size of a regular sheet of paper. A regular sheet of paper. On it, and I don't care, it's your poster. You can make your poster like this, you can make it like this. You can be kind of cool like this, but I want you to use the full sheet. Somewhere on there, I want you in big letters write out potential energy and its formula. My formula's there. And then we discussed 4 different types of potential energy. Well, I discussed 3 of them. There's one you still need to look up in the book. We have gravitational potential energy, elastic potential energy, chemical, and the 4th one, nuclear energy. I'm going to leave that one for you to read in the book. And I want you to put on your poster potential energy, the formula, P equals mgh, and then somewhere I want you to put gravitational potential energy and draw a picture that represents that. Write out elastic potential energy, draw a picture that represents that. Write out chemical energy, draw a picture that represents potential chemical energy. And potential nuclear energy, draw a picture that does nuclear energy. You will put that into your notebooks and show it to me, and that'll be your easy notebook grade for the day. Any questions on that part? Part 1. Now we go to part 2. Part 2, there's an online worksheet. It's largely going to be some word problems where you're going to have to plug the numbers into one of these 3 versions of the potential energy formula. You'll be given the mass and height and have to get the potential energy, or you'll be given the height and potential energy and have to get the height, or you'll be given the height and potential energy and have to find the mass of the object. That's why I said write this down, and I will leave it up here so you can come up here and press the button if you need. Other words, each person needs to make me a little mini poster and show it to me, and then do the worksheet and show it to me. Are there any questions on that?
No.
Awesome! Have fun and play with potential energy.